In this lab we're going to be working on the Raspberry Pi and the play bulb candle. So here's my Raspberry Pi. It has a sense hat on it. You don't need a sense hat. I'm going to be running this headless because I've already run this and got the Raspberry Pi configured. So all I'm going to do is plug it in with power. That's all it will need. And the candle, turn it over, there's some batteries in there, and we'll switch it on. I've already installed the new out-of-the-box software on my Raspberry Pi. There is a video on the Raspberry Pi org page which will guide you through how to get that started, and I've also configured my Pi to have remote access, and that's how I can run it headless. Remote access, again, information is on the Raspberry Pi org page. I've configured SSH, so I can use a terminal window to access the Pi, and you just follow the instructions on the org page. And I've also configured VNC, so I can have a graphical user interface. I won't actually use it. I'll show you how to start it up, but it's useful to have if you want to do some graphical user interface. We won't need this in this lab, but again, as I said, it's quite useful to have. So I'll go onto a terminal window and SSH into my Raspberry Pi. Now, to SSH you have to know the host name, and of course you'll run this hostname -i on your own machine. And if you do want a VNC, you'll run it like this: open VNC, Pi is the default user, and the IP address that we've just configured using hostname -i. You have a port of 5901 and it counts up from 5901, so the next one would be 5902, but we've only got one VNC session running. Tap in the password that we configured, and there we are. We have a graphical user interface that we can use of the Pi. We won't use that, so we'll shut that down. We'll be doing most of the work in the terminal window. First thing you have to do is update the Raspberry Pi, and you should do this periodically anyway. So we're going to run an apt-get update. The -y means don't ask me for confirmation, and we'll also run an apt-get upgrade. So the update gets hold of the updates, and the upgrade actually applies them. And again, the -y says don't prompt me. Yes, I am sure. Now for the next part, where we're going to upgrade Node and Node-RED, there is a known problem with certain internet providers. So we have to go into the etc. directory and look at the file resolve.conf. And in there you need to uncomment name servers, and I put in 8.8.8.8, which is the Google DNS provider. And that should work. And then once you've done that, you need to restart. You need to restart by doing a shutdown -r now. Now obviously I've already got the change because you can see it. So now we can actually upgrade Node.js, because the application that we're going to be running is a Node.js application. And to upgrade Node.js, we actually run a update Node.js and Node-RED script, which will update Node.js. Node-RED along with Node.js comes pre-installed on the Raspberry Pi distribution. We do want to upgrade it. We won't actually be using Node-RED, but I will show you how to get it started. So Node-RED start, and then all you have to do is access it through a browser. And the browser does not have to be running on the Pi. We can do this on our own machine because we know the IP address, and here are some flows that I had created previously. Yep. What you do get with Node-RED on the Raspberry Pi is a series of nodes I've actually added the sense out ones, but a series of nodes that allow you to control and communicate with the Pi through Node-RED. And you also have the IoT node, so you can actually send and receive instructions from the IoT platform. So let's Control C. That doesn't actually stop Node-RED. To stop Node-RED, you have to run the script Node-RED stop. Now it's stopped. And now we're ready to install the prerequisites for the Node.js application that we're going to be running to communicate with the candle. We have to install some Bluetooth libraries. I already got them installed. We'll say I'm already at the latest version, but you need to install them to make sure they are installed. And they just create a directory in which you're going to download some code. Of course, I've already got this directory, but you would have to make the directory, and I've also downloaded the code as well. But to download the code, you create a directory in which you're going to download the code. I will create a temporary one here that I'll get rid of later. And you run a git clone on the link that you'll find in the documentation for this lab. I've made a mistake here. I've put github.co. It should be github.com. So this will time out with an error, and then I'll correct that with the correct library. So this will time out because the library doesn't exist. Tap in github.com, Marcus Van Kempen, and playbook.git. So here is the directory. It's a Node.js application. You'll notice that it has dependencies which need to be installed. And it has two JavaScript applications, two Node.js applications. So we'll install the prerequisites, and that's how that's done. So we'll get rid of this temporary file because I've already got everything downloaded. And I'll just make sure that I've got everything up to date in case Marcus had made any updates. So to start off with, we run node pip b with a series of question marks, which is essentially a list, and the application's found our candle. It's also told us its ID, which happens to be its MAC address, which is useful because we know it's going to be unique. And we run pip b, with the ID and a setting of blue, and we can see that our lamp turns to blue. So we've got the Raspberry Pi communicating with the play bulb candle. We now need to get to be able to communicate with the Raspberry Pi. So it has a hardware address, which again is a MAC address. So we go onto the Internet of Things and we'll register both the candle and the Pi as devices. Now I've already registered them, but what you will do is click on Add Device. So let's start off with the Raspberry Pi, which is acting as a gateway. Its MAC address we know is going to be unique, so we can use that as its device ID. This does not have to be a MAC address that you use for the device ID, it just has to be unique. But we can use the MAC address, and I normally would prefix that with some other identifier so that I can actually distinguish the device. I will generate a token. I will use a token. Make sure that your token is unique to you, and we'll cancel this because as I said, I already have the device registered. And we'll also register a play bulb device. The device types you should have already created in the previous lab 1. And we know the candle's MAC address as well, so we'll use that as its identifier on the Internet of Things platform. Once again, we provide a token, and we'll cancel this. As I said before, I've already registered these devices. One other change, there's a device.json file in the application on the Raspberry Pi, which tells the application how to communicate with the Internet of Things platform. So you have the organization, the domain, the type, which happens to be a play bulb, the ID, and this is the ID that I've registered on the IoT platform, and the token that I've registered on the IoT platform. So now we run the second application, pip.iot.js, with the device ID on the Pi, and the application is now communicating with both Candle and IoT platform. So now we'll go into our Node-RED instance. This is our Node-RED instance running on Bluemix, not the Raspberry Pi. We'll create a new flow. We'll take an inject node, a function node, and an output IoT node. So we'll wire these together. Let's give the injector a meaningful name, and in the function node we'll write in some code that sets the red, green, blue settings to red, and we're going to send a command set color. This message gets put onto and this command gets added to the payload. So let's look at the IoT node. It's a Bluemix service. This is going to be a device command, and make sure that you do set it to device command. The device type, play bulb, and the device ID, and set color as the command. So we'll deploy, run it, and the lamp should turn to red. So now we're able to control the lamp from our application running in Bluemix. If we go to the GitHub repo where the application is, there is a sample flow. If we take a look at in raw, copy, and then import into our Node-RED instance, you actually see that the flow that we created is actually a sub part of these samples already. And it also has a listener on IoT. So we'll just get rid of this node and just wire to our IoT because it's been configured with our device ID. Set the color to green. We see the inputs coming in. Run it, set it to green, and then run it, set it to red. And let's take a look. Set it to green and set it back to red.